back to another video of CambiHub, and in today's video we'll be starting with a pseudocode 101 series where we'll be covering all of the pseudocode topics, including the theory ones, and also we'll include obviously the practical part of it. We'll also include the 15 marker, how to solve the 15 marker, and everything that's there in paper 2. A video has already been made for Boolean logic and for databases, which you can see on our channel. If you go to our channel and if you go to the playlist option, there you'll find a playlist called Computer Science, where you'll find all of the videos. Even of theory series, we have completed chapter 1 to 6, right? So all of the chapters are completed. If you want the theory explanations, you can see. We'll be bringing more content for more subjects, for more IGCSE subjects, and also for computer science, where we'll be bringing topical questions and much more things. We'll be doing solve past papers. As of now, as of right now, we'll be doing pseudocodes, right? And we'll be starting with the theory part of it for paper 2, because obviously a great amount of theory is also asked regarding pseudocodes and programming, right? In your book, this might be if you're using the Hodder education book, or if you're using the Cambridge University Press. If you're using the Hodder one, then it will be chapter number 7, chapter 8, and chapter 9, if you will see, right? These all are the chapters that we'll be covering if you want to see from the book, right? Starting with the first topic, that is the program development life cycle. So before we continue with the lecture, let's discuss what are the topics that we'll be studying today. We'll be studying the program development life cycle in detail. We'll be studying analysis, abstraction and decomposition, which is a part of analysis, design, where we'll be doing structure charts. We'll tell you how to solve it. We'll be seeing a solved example. Flowcharts, where when flowcharts also we'll be seeing a solved example. Few pseudocodes, and we'll also be discussing how decomposition is done using subsystems. We'll be learning coding and iterative testing and testing. Obviously, this talks about the development of a program, right? So when we develop a program, what do we mean by program? It can be an app, it can be anything which requires a coding, right? Anything which requires coding. We all know what coding is. I'm explaining in very layman language, so that for people those who are not very familiar with technical terms can also understand. So program development life cycle is obviously the life cycle or the stages for developing a program. What are those stages? Number 1, we have analysis, we have design, we have coding, and we have testing. These are the 4 stages which we'll be covering. Let's start with the first stage, which is analysis, right? If you talk about analysis is when we have a problem, right? Obviously, whenever we are making a program, the first obvious thing that we have to do is we define a problem, right? If there's no problem, if there's no issue, then why are we creating that application, right? So before even starting the development of a program, we need to identify our problem statement, right? And we need to break it down, right? A problem should be clearly defined. Obviously, a problem should be clearly defined and set in a way that anyone can understand its need and its solution, right? Things should not be in the air. It should all be settled down. Everything should be planned, right? Obviously, let's forget about program development life cycle, right? Let's talk about if you want to do a school project, right? If you want to do a school project, obviously the first stage requires us planning, understanding what the topic means, and breaking down into smaller parts, or deciding its solution, right? The solution should also be well defined. The solution should also have its own ways of solving the problem, right? So this is how a problem should be, right? Now that is what we have to do in analysis, breaking down a problem, right? Now there are 2 stages which we include in the analysis stage, which is abstraction and decomposition. When we talk about abstraction, we extract key information. So we extract what all is needed, we extract the keywords, we extract the key information, and we discard irrelevant data, right? So we'll discard all the data that is not relevant to us, that is not needed to us. That is what we do in abstraction. Whereas when we talk about decomposition is when we divide a problem into smaller parts. Obviously, we have a big problem. Considering it as creating a flowchart. How would you create a flowchart? You would first name the topic, and then start creating its branches, and then start putting boxes, right? That's what we're doing. We are breaking this problem into parts. So this is what decomposition is. Let's move on to the next topic, which is which is design. I'll just move ahead. If you want to take a screenshot of the notes, obviously you can. And I recommend that you take a notebook, a paper and a pen while I'm teaching this pseudocode series, right? So that it's crystal clear to you. Moving on to the next stage, which is designing, right? Now, what do we mean by designing? Designing doesn't mean inviting a graphics designer to design the interface of the code. That is not designing, right? Designing includes, see, once we have created a program, right, we would now want to put that program into a rough structure, right, for us to refer to, right? So we can do it in many ways, right? We can create a structure chart, right? What is a structure chart? We'll study that, right? We'll also learn how to create structure charts, and your paper also has questions which asks you to create structure charts. We have flowcharts. Flowcharts everybody knows, but obviously IGCSE flowcharts are a bit different, right? We learn that also. And pseudocodes, right? Now what are pseudocodes, right? They come under the design stage. So pseudo word means false. So pseudocode is a false code. It's not a real programming language. It does not exist on a computer. It is always written, right? Now why do we create pseudocodes? What is the need to create pseudocodes when we have Python, we have Java, we have programming languages? Why do we use pseudocodes? Let's say you are the coder and we also have a designing team. They design the interface of your app, right? How would your designing team communicate with you that all of these things, this interface should be here, this triangle should be here, there should be a rectangle box, with this color, with this design? How would they do that, right? So the designing team cannot learn all of the programming languages, right? That's I think that's the problem of software engineer. So they use pseudocodes. They write everything in a rough language, in a structured language which does not have specific rules. They create a rough language with basic concepts of programming, and they give it to the programmer. Now it's programmer's job to convert that pseudocode, that structure chart or that flow chart into a proper code. And that's why we move to the next step, which is coding and iterative testing, which is the third stage, where the actual code is written in a proper programming language such as Python, Java, whatever it is, right? That is done in coding, right? How do we do coding? For coding, we have a program, right? This program is broken down into modules. This program is broken down into specific modules. We break the program into specific parts, modules, and each module is written using a suitable programming language like Python or Java. When we talk about iterative testing, so once we create these modules, it's necessary to test these modules to see if they work as expected, right? Whatever output we want is what we are getting from those modules. To check that, we do iterative testing. So we do repetitive, like iterative means repeating, a looping, right? Iterative means repetitive, right? So repetitive modular tests. So we'll keep on testing a module until it works as expected, right? Or until it gives expected output, right? So repetitive modular tests is iterative testing. Now the fourth stage is also called testing, but that's different. Iterative testing is when we create modules of a code and we are testing each module again and again until it does not give us the expected output. Let's move on to the last stage, which is testing. Now, the last stage of the program development life cycle is called the testing phase. What do we do in the testing stage or in this testing phase? Set of programs are run. So whatever program we have created, a set of these programs will be run using test data. What do we mean by test data? Suppose what my program does is, I'm writing a very simple program. Suppose my program has a variable A and my program has a variable B, and it does a sum where it adds A and B, right? Now I will use test data to test this whole program. What do I mean by test data? I will, instead of A, when I'll output my program, and instead of A I'll enter 2, and instead of B I'll enter 3. And as per the code, the output should be 5, right? So I'll check if I'm getting 5 or not. What is this 2 and 3? These 2 and 3 are test data. So I'm putting test data, sets of test data into my program and running it and seeing if the output is as expected or not. So I'll put 2 and 3 instead of A and B, and ideally the program should give me 5 because it's adding A and B. So I will test that if it gives me a 5 or not, right? So this is the last stage, testing. Let's move on to the next topic. Let's come to the first design, right? The first example of how to design, right? That is structure charts. And this is asked in the paper. They'll ask you to create structure charts. How do we do that? It's pretty simple, right? Structure charts are pretty simple. You just need to follow the question directly. And the example that I'm taking right now, which is a GPS navigation system, is a classic example. Most of the teachers will give you this example for structure chart. It has also been a part of few of the papers provided by Cambridge. Let's see how do we do it. First of all, how would a GPS navigation system work? We all have used Google Maps, you all have used Apple Maps. How does that happen? First of all, right, we write the thing, set navigation. We write a topic. We have to set navigation, right? Then, how will this navigation work? Firstly, this navigation will ask me to input destination, right? This navigation will ask me to input destination, and then this navigation will output directions, right? So these are the two subsystems we have created. But if you see, still they don't perform a single task. So we need to break this subsystem further, right? How would this input destination work? First, it can ask you to enter a new destination, or it can ask you to go with a saved destination that you have already saved. Right? Now again, you can break this further, but we'll stick to the question, right? Whatever the question says, there's no question right now, but you will stick to the question, right? How would we divide output directions? How will we divide output directions, right? How can directions be given to you? Either it can give you a map, right? Either it can give you a map, or it will give you a list, right? Either it will give you a map as a direction, or it will give you list, right? Then it will give you street directions. Follow the street, turn right, then turn left. It will give you either a list or a full-fledged map, right? So this is how you create a structure chart for a GPS navigation system. Just keep this in mind that in structure charts, there should not be curved boxes. It should be a proper rectangle, right? There should be no arrows like this. No, that should not be done, right? Then there should not be, the branches should be in a settled way, right? So these are few things that you need to make sure. The boxes need to be square, all of the boxes need to be same, right? And there should be no arrows to the directions, to the direction the chart flows, right? There should not be any arrows. Let's move on to the next question, or the next designing stage, which is flowcharts. Coming to flowcharts. So for flowcharts, we have few specific symbols that you need to learn, right? What are those specific symbols? Number one, this symbol, an oval shape, is used to represent start or stop of the flowchart, right? This is generally not even used, but it's your choice, you can use it, right? Then this rectangle, a sharp rectangle, is used for a process, right? Whenever we want to show a process in the flowchart, we'll use this rectangular box. A rhombus, a parallelogram, right? A slanted sides, right? Slanted breadth and a length, right? We use this to either input data or output data. And last one is decision box, which is a rhombus, a diamond shaped box, which is used to make a decision whenever you want to make a decision. And these are the flow lines for the flowchart. These are the flow lines for the flowchart. Let's solve a sample question. Question says, create a flowchart to add students term 1 and term 2 score. If the total score is greater than 50, output the student has passed the test. So we have to input students term 1 and term 2 marks. We have to add them. And if that total is greater than 50, then we need to output that the student has passed the test. Right? Let's start our flowchart. So to start the flowchart, we'll use a start box. Right? Then we want to input data, right? Flow lines need to be very clear. I don't have space here, so I'll compromise that a bit, but they need to be clear here, right? You can take as much space as you want. Just make sure you don't exceed the page, right? Okay, we'll click start. We'll say start, right? Then we'll input data, right? So for input we'll use a rhombus, parallelogram. So we'll input term 1 and we will also input term 2, right? Instead of writing like this, you can also write this as input term 1 comma term 2, right? You can write it this way, right? Once we have taken the input for term 1 and term 2, the next job is to total the score, right? So totaling is a process. We'll show it in a process box. So total score what do we need to store in the total score? We always use this assignment operation to store something. So what do we store in total score? Term 1 plus term 2, right? This will be in a process box because totaling is a process, right? Then we want to make a decision. We want to make a decision that whether the score is greater than 50 or less than 50, right? So let's make a decision. We'll say if, see, all of the keywords need to be capital, like input, start should also be in capital letters. You need to make sure that all of the keywords, right, like stop, start, input, if, else, right, all of these things need to be in capital letters. Right, start, input term 1, term 2, total score is term 1 plus term 2. Now if again a keyword, that's why it's in capital. If total score is greater than 50, if total score is greater than 50, again this needs to be in a decision box, so you need to utilize space properly. How will we utilize that? We'll create a large rhombus, right? If total score is greater than 50, then what do? We will output student has passed the test. Right, we'll output the student has passed the test. Again output, so it will be in a parallelogram. Right, now we want to end our code, so we'll write stop and we'll end our code. So this is a basic flowchart, a very basic flowchart. However, you will get pretty complex ones in the paper. Don't worry, we'll practice a lot in this series. So this is just an introduction to you for the flowchart. I'll just get aside. If you want, you can take a screenshot, solve the question. Let's move on to the next topic. Okay, now the third part is pseudocodes, but the theory and practical we will start from the next video. This was just an introduction about the program development life cycle, right? From next video we'll be starting with pseudocode theory and pseudocodes practical, right? If you want to visit our website is a learning portal where you can access worksheets, past papers, notes for free. Please go to www.CambiHub.com. We also have a student WhatsApp community where you can ask doubts us. You can ask us 24/7. You can find people who can help you for all of the IGCSE subjects. You have for IGCSE, A-levels and IVDP at this particular time, 2024. If you're watching this video afterwards, then we might have more things. You'll find the website link and the community link, WhatsApp community link in the description below. Do join the community, right? You'll get a lot of help, lot of resources. If you want to mail CambiHub for business inquiries, support@CambiHub.com. If you want to ask your doubts, obviously comment section is there. But if you want to personally mail me, you can mail me at Pranay@CambiHub.com. This is Pranay Arora signing off from CambiHub. Let's meet you in the next video. If you're watching the playlist, then let's see you in the next video.